We are solving October 2023 Pure Math 1 paper. In the previous video we finished till question number 6. Now let's start question number 7. This is from differentiation. You have a function given. It's not a function actually, it's f dash of x. Okay, find the value of the gradient at p. So basically you just plug in this point, replace x by 4 straight away. So you will get f dash of 4 is 4 times 4 square plus 10, 7 times 4 power half, everything divided by 4 times 4 power half. So you will get 64. I'm going to use my calculator now. 4 square times 4 is 64 plus 10 minus 7 times 4 power half. 4 power half is 2, so 7 2s are 14. That's 60. So we have 60 divided by 8, which is 15 4s are 60 divided by 2. 15 divided by 2. That's the answer. That's the gradient at P, or the gradient of a tangent. Now double line. I put the question separately here, double line. They want you to find the equation of normal. We find the slope of the tangent in the previous part as 15 over 2. So slope of the normal will be negative reciprocal of this, negative 2 over 15. And we have a point given, P of 4 comma negative 1, P of 4 comma negative 1. So the equation is y minus y1 is equal to slope times x minus x1. So basically if you multiply throughout by 15, because they want in this form actually ax plus by plus c, where a, b, c are integers. So to get rid of the fraction, multiply everything by 15, you will get 15y plus 15 is equal to minus 2x plus 8. So basically you will get 2x plus 15y, 15 minus 8 plus 7 is equal to 0. That's the equation of the normal. Now part B of the question says find f of x. We have f dash of x. We need to integrate this and use the point P of 4 comma negative 1 to find the value of c. So we need to write this properly first. We write it as divide each term by 4x power half. 10 over 4x power half, 7x power half divided by 4x power half. So 4 will be cancelled. X power 2 minus half is 3 over 2. 10 over 4 is basically 5 over 2. Put it as a x power minus half. X power half will be cancelled. You will get 7 over 4. That's f dash of x. Now we have to find f of x now. F of x is basically integral of this x power 3 over 2 plus 5 over 2 x power minus half minus 7 over 4 dx. Integrated, you'll get x power 3 over 2 plus 1, which is 5 over 2 by 5 over 2. X power minus half plus 1, which is positive half by positive half. 7 over 4x plus c. That's f of x. That's all, just an integration, basic integration. Now we need to sub in this point in here to find the value of c. That's what we are going to do next. So when I sub in the point, replace f of x by negative 1, x by 4, it's basically 2 over 5 times 4 power 5 over 2 plus 5 over 2 divided by half. The 2 will be cancelled. You will get just 5 x power half, replace x with 4, minus 7 over 4 times 4 plus c. 4 power 5 over 2. I'm going to use my calculator. 5 over 2 is 2.5. I got 32. 32 times 2 over 5 is 64 over 5. 64 over 5. 4 power half is 2, so you'll get 10 minus 7 plus c. So c is bring everything to the other side, so it's going to be negative 1 minus 64 over 5, and then minus 10 plus 7. That's c, negative 84 over 5, negative 84 over 5. And then you have to write the function finally with the c value. So the function is negative 84 over 5. This is the function. If you don't write the function with the c value, you will lose 1 mark. That's all. That's how you find the function from the first derivative. I'm going to move on to the next question. Question number 8 now. Curve C1 has equation, C2 has equation. Show that C1 and C2 meet when this is equal to this. Basically, you have to combine these two equations and then frame this equation. You see how I'm going to combine this? We know y is equal to this, right? So I'm going to put this y in here. So x times x cube minus 7 over 2x minus 5 is equal to 15 over 2 minus 5x. I open the bracket here and multiply throughout by 2 to get it of the fraction. So I will get 2x power 4 minus 14x square minus 10x is equal to 15 minus 10x. Minus 10x plus, bring the minus 10x here, will be cancelled. So you get, sorry, it's not 14x square, the over 2 will be cancelled, 7x square. So we'll get 2x power 4 minus 7x square minus 15 is equal to 0. That's the required equation. That's it. You just need to combine it carefully. Part B of the question says, the curve C1 and C2 meets at point P and Q. Find the distance PQ. So basically, we need to solve this equation and find the points, the x coordinate and y coordinate of the points where the C1 and C2 meets. So you need to solve this equation first. That's why this question got 5 marks actually. So we need to solve 2x power 4 minus 7x square minus 15 is equal to 0. So if you look at P1 chapter 2 quadratics, there is a topic called functions, and if you go to the particular exercise there, you will see similar questions there. You need to change it to a quadratic. You can take y as or p as x square, so p square will be x power 4. Sub in here, you will get 2p square minus 7p minus 15 is equal to 0. So I'm going to use my calculator to solve this. Shift number 5 equation number 3 quadratic, 2 minus 7 minus 15. I got 5 minus 3 over 2. So P is 5, P is minus 3 over 2. But you need to write one more step here. P minus 5 times, if you don't write this, you will lose more. Is equal to 0. So you got two P values. P is equal to 5, P is equal to minus 3 over 2. Now replace P back to x square. So this is x square is 5, x square is negative 3 over 2. You cannot find the square root and find x here, so no solution for this one. Here x is plus or minus root 5. So for two x values, you will get two y values. You need to find y using any one of the equation. I'm going to use this equation to find y now. Or you can use this also. I think this will be lot easy. The first equation. So I'm taking the first equation to find y now. If you replace find y is equal to 15 over 2x minus 5. So if x is root 5, y would be 15 over 2 root 5 minus 5. Rationalize the denominator, you'll get, maybe you can combine it first. 15 minus 10 root 5 divided by 2 root 5. Rationalize the denominator. It's up to you how you want to find the value of y, but you cannot have a third in the denominator. So you will get 15 root 5 minus 10 root 5 times root 5 is 50 divided by 10. Take 5 as a common factor and cancel out. You'll get 3 root 5 minus 10 divided by 2. That's the value of y. Now that's the first point. The first point is square root of 5 for x coordinate, 3 root 5 minus 10 over 2 as y coordinate. Now replace x by negative root 5. You will get negative here, and then this becomes positive. You have a negative 2 root 5 here. Rationalize the denominator. You'll get plus by negative 10. So you'll get plus by negative 2. So the second point is minus root 5 comma 3 root 5 minus 3 root 5 minus 10 divided by positive 2. This is same as this actually. Instead of negative 2 in the denominator, I multiply the numerator by minus 1. So we got the 2 points already. We need to find the distance now. You can do two things. You can just simply apply the distance formula, but since there are so many surds involved here, the distance formula will be a little trickier. In other words, what you can do, if you draw the x and y coordinate plane, let's say minus root 5 is here, plus root 5 is here. Okay, it's not a parallel line actually. If it's a parallel line, if it's a parallel line, we can find the difference. Not a parallel line actually. So you need to use the distance formula. When you use the distance formula, PQ is equal to square root of x2 minus x1 root 5 plus root 5 whole square plus y2. The first point is 3 root 5 by 2 minus 10 divided by 2. I'm going to put it as 5 minus y1 minus 3 root 5 by 2 minus 5 whole square. This is going to be 2 root 5 whole square. Here the minus 5 and plus 5 will be cancelled. You will get just 3 root 5 whole square, square root of. I'm going to put it in my calculator to find this value. So square root of 2 root 5 square plus 3 root 5 square. I got square root of 65 units. That's the distance between these 2 points. Question number 9 from radians. Actually, this is the question from radians. I think we solved a similar question before. I told you guys that's a question from radians. Actually, that was question number 5. That was from trigonometry, not from radians. Actually, this is a question from radians. Okay, for radians question, you might get any weird looking figure. It's completely fine. Just read the question carefully and look at the figure and understand it. Figure 3 shows the plan view of area being used for a ball throwing competition. Okay, competitors must stand within the circle C, throw a ball as far as possible into the target area PQRS. From here they have to throw into in this area shown shaded in figure. Okay, circle C has center O. This is a circle with center O. P and S are points on C. You can see that. And then OPQRSO is a sector of a circle with center O. Okay, that's a bigger circle maybe. The length of PS is 0.72. I put the figure here separately. This length PS is 0.72. This arc length, this little arc length is 0.72. This arc length. and the angle is also given. Its POS is angle POS 0.6 radians. This angle is 0.6 radians. We know arc length is equal to r theta, which is given as 0.72. Now back to the question. Show that OP, the radius is 1.2. It's a 1 mark question. So to find this radius, you sub in the theta here. So r is 0.72 divided by 0.6. 1.2. So it's given in meter. So the answer for this is 1.2 meter. That's the answer. Let's move on to the next part now. Given that the target area PQRS is 90 meter square. Okay, now here probably I'll just take the figure separately. Okay, now the question says the target area PQRS is 90 meter square. That means this area is shaded area is 90 meter square. And then the length PQ is x meter. This length PQ is x. We know this radius is 1.2. We just calculated. We know this angle. Now the question wants you to find part B, the question wants you to frame an equation in terms of x. So what we can do to frame an equation of x, we are going to use the area of a sector half r square radius. We are going to take this whole thing as radius. So x plus 1.2 whole square times theta. Theta was given in the part A 0.6. That's the area, basically the whole area, actually this whole area, the shaded plus this little area. If you minus the area of the little shaded, you will get 90 meter square. So to find the shaded area, you take the bigger area minus smaller area. Minus smaller area is half r square times theta. If you open the bracket and simplify, you can frame the equation already. So what I'm going to do, I'm going to multiply everything by probably 2. So x plus 1.2 whole square is x square plus 2ab 2.4 whole square plus 1.2 12 square is 144. So 1.44 times 0.6 minus, here the half will be gone when you multiply by 2. You get 1.2 square times 0.6 is 864. 0.864 minus 180 is equal to 0, because we are multiplying every term by 2 to get rid of the fraction. Now all you need to do is just open the bracket for this one. Open the bracket and simplify, you'll get the answer already. So I'm going to open the bracket now. 0.6 x square 2.4 times 0.6. 2.4 times 0.6 is 1.44x plus, when you multiply these two, 1.44 times 0.6, 0.864 minus 0.864 minus 180 is 0. This will be cancelled. So we have 0.6 x square minus 1.44x minus 180 is equal to 0. You need to have 5x square, not 0.6x square. So you need to multiply 0.6 by a number. In fact, you need to multiply the whole equation by that number. To find the number, you can divide 5 by 0.6. That's 25/3. Okay, that's a recurring decimal. If you multiply everything by 25/3, let's see what will happen if we multiply 1.44 by 25 over 3. We got 12. What if we multiply the last term by 25 over 3? Yeah, that's correct. So multiply throughout by 25 over 3. You get 5x square minus 12x. Sorry, it should be plus, right? Minus 1500 is equal to 0. We framed the equation already. Okay, you have to carefully simplify it. That's it. So part B is over. We framed the equation already. Now part C, hence calculate the perimeter of the target area PQRS. To find the perimeter, we need to know this PS, the arc length, which is given in part A. It was given as 0.72. This little arc length is 0.72. And then we need to find X. Take this X also. We know this angle, and this is from the previous part. In part A it's given 1.2. This is 1.2. So if you know the angle and the total X also, we can find this arc length also, so we can find the perimeter. So to find X, in the previous part we have a quadratic, right? Solve this quadratic and find the value of X. Shift 5 equation 3 quadratic. 5 equal 12 equal minus 1500. So the first value, the X is representing a length actually, so it has to be positive. So when I change it, I get positive. Okay, so I'll take this value. How about the next value? It's a negative number, so ignore it. So the answer is minus 6. So the value of X is basically minus 6 plus 4 root of 471 over 5. Okay, so that's how we find the perimeter. Now the perimeter is this little length and X plus X. So it's basically 0.72 plus 2 times X. So 2 times minus 6 plus 4 root of 471 over 5 plus this arc length. How do we find this arc length? R theta, the radius is X plus 1.2. So X is this plus 1.2 times the theta, this theta. The theta was given as 0.6 actually. So if you calculate this, you will get the perimeter. So I'm gonna try to put everything in my calculator and see what happens. .72 plus 2 times minus 6 plus 4 root of 471 divided by 5, close the bracket, plus open bracket, minus 6 plus 4 square root of 471 divided by 5 plus 1.2, close the bracket, times 0.6. Okay, I'm gonna change it to a decimal number, 43 point something something something. They want the answer to the nearest meter, so it's a 43 meter. That's the answer. So we are done with question number 9. Let's move on to question number 10. We have a graph given, looks like a part of a cosine graph, but the question says the graph is this: 3 cos y is equal to 3 cos x over n. The moment you multiply the function by 3, this becomes 3, this becomes negative 3. Okay, now in part A The C1 cuts positive x-axis for the first time at P of 270,0. This point P is 270 degree, 0. And then, as shown in figure 4, state the value of n, state the period of C1. We need to find the value of this n. Okay, what you need to understand here, if let's say you have a cosine graph here, this will be 90, this will be 180 and all. This will be 180, this will be 270 and all. That's cos x. Now if they ask you to sketch cos x over 2, if you have learned the stretching properly, it's mentioned there clearly, when you divide x by 2, you need to multiply the x coordinates. So you need to multiply these coordinates. 90 multiplied by 2, it becomes 180. So the first point becomes 270 because 90 has been multiplied by 3. That tells us n is equal to 3. So the value of n is equal to 3. That means you are multiplying it actually. So when it comes to period of the graph, the period of cosine graph is basically 360 degree. Now you need to multiply it by 3. So it's going to be 900, 1080. That's the period of C1. That's all. Now next part B says find the coordinates of Q. Okay. Let me put the graph here again. So we know the graph is y is equal to 3 cos x over 3 degree. You know this is 270 and this is 3, this is negative 3. So the y coordinate of this point is negative 3. How about the x coordinate? You need to take the second minimum point in cosine graph first and multiply by 3. This would be 90, 180, 270, 360, 450, 540. This point is 540, negative. So when you multiply 540 by 3, 540 times 3 is 1620. So the point coordinates of the point is 1620 degree, negative 3. That's all. You don't need to write anything else. But always compare with the basic cosine graph and find out. Now let's move on to part C of the question. A curve C2 has equation y is equal to 2 sine x plus k. No graph is given. The point R and the point S lie on C2. Given that A is a constant less than 90, find the value of k. So here we have 2 points. So the best and easiest way to solve it, instead of looking at the graph, just sub in the points here and frame 2 equations and solve it. I'm going to replace y by 12 over 5, x by a. So 2 sine a plus k, that's equation 1. And sub in the next point, minus 3 over 5 is equal to 2 sine of minus a plus k. Take it as equation 2. You should know this sine of minus theta is equal to minus sine theta. Cos of minus theta is positive cos theta. Tan of minus theta is minus tan theta. I can take note of it. So this becomes minus 2 sine a. So when you add these 2 equations, these 2 will be cancelled. You'll get 12 over 5 minus 3 over 5 is equal to 2k, which is basically 9 over 5. So k is equal to 9 over 5 divided by 2, 9 over 10. That's the easiest way to find the value of k. So that's all. Let's move on to the next question now. Question number 11 now. We have a figure given. Figure 5 shows part of the curve with the equation f of x, which is a quadratic curve and a straight line also. Part A says write the quadratic in this form. That's just completing the square actually. Take 2 out from the first 2 terms, x square minus 6x plus 14. Apply the completing the square method. half of the coefficient of x is 3, so you put plus 3 square minus 3 square plus 14. So that's just basically x minus 3 whole square minus 9. By keeping 2 outside, you should know how to do the completing the square method. Take 2 and multiply everything, you'll get 2 times x minus 3 whole square minus 18 plus 14. You'll get 2 times x minus 3 whole square minus 4. Compare these two. A is equal to 2, B is negative 3, C is negative 4. It's an easy 3-mark question. And definitely you will get this type of completing the square method as one of the question in the board exam. So make sure you practice this. Part B says, given that the curve has a minimum point at P, you can see from the figure the minimum point P is mentioned here. How do we find the minimum point? We have the completing the square method here. The answer from part A, 2 times x minus 3 whole square minus 4. So the easiest way to find the turning point of a quadratic function, when you have this, take this number, change the sign, take the number standing all alone here. That's the turning point. 3 comma negative 4. That's the easiest way to find the turning point. Now part C says, the line C intersect at line intersects C at minus 1 comma 28, as you can see this point, and at P also. Find the equation of the line. We need to find the equation of the line. So basically you have 2 points already. This P is 3 comma negative 4, and you have one more point. You can find the slope and find the equation already. So slope is y2 minus y1 divided by x2, sorry, you need to take it as x2 as minus 3. So which is 32 over minus 4 is minus 8. So the equation, take any one of the point as x1, y1. So y minus y1 is equal to slope times x minus x1, or you can use y is equal to mx plus c also. The question says they want the answer in this form. So y is equal to minus 8x plus 8 3s are 24 minus 4. So y is equal to minus 8x plus 20. That's the answer for this part. Y is equal to minus 8x plus 20. That's all. Part C is over. Let's move on to part D. Finite region R shown shaded in figure is bounded by L and C. Use inequalities to define R. We need to find the inequalities that define this shaded region. So always remember, when the shaded region is above or on the right hand side, use greater than or equal to. If it's below or left hand side, use less than or equal to. This is for a solid line, this is for a dotted line. So let's look at the boundary lines one by one. There are 4 boundary lines, 1 2 3 4. First look at the curve. The shaded region is above the curve, so you need to use this for solid line. Y is greater than or equal to. And then below the line, so y is less than or equal to. And then if you take this line, the equation of y-axis is x is equal to 0. On the right hand side it's shaded, so x is greater than or equal to 0. And then here the above is shaded, y is greater than or equal to 0. You need to write all these 4 inequalities to get 3 marks.